But that's about the extent of the usefulness, or at least from what I've found, the usefulness of standard form of a line. What's really going on, what's really happening, is the slope-intercept form of a line. Well, before I give you slope-intercept form, I need to define what a slope is. I've kind of already given you what an intercept is, but what's a slope? Well, when you're going skiing, going down the slopes, zip, zop, zoop, bop, it's kind of a decline, right? It's, if you're familiar with skiing or snowboarding, there's different levels of difficulty depending on how steep the slope is. So like the bunny hills are really shallow for the beginners, but then like the black diamonds and then the double diamonds are really steep. That's about what a slope is. A slope is just telling you the relative steepness of a line. That's it. Now, to find the slope, there's actually an equation that you can use, a formula that you can use to find it. For whatever reason, the letter m is the variable that we use in place of the concept of the slope. Don't ask me why. M is the slope. The slope is defined by the change in y over the change in x. Oh, and this always tripped me up. This is called the slope formula. Actually, I haven't given you the formula yet. I'll explain what these are in a minute before I go on my rant. They give you a slope formula, which is a formula to tell you what the slope is. But then they teach you what the slope-intercept form of a line is. They both have the word slope in it. They both have the word form in there somewhere. It was just so confusing for me. So all you need to do, since you only need 2 points to determine a line, you can just pick any 2 points, any 2 different points that are on that line. We're going to plug in their coordinate values into this formula. Now this can get really confusing, so I'm going to go through this one step by step. I'm actually going to use these 2 coordinate points to start. Okay, so I found the 0, -2 first. You just need 2 points on the line. What these y's and these x's are, I'm pretty sure I've told you what a subscript is. It's just kind of like a last name. Hi, what is your name? X. Oh, I met an X earlier. Oh, I'm X2. Oh, okay, so that's the way that I can differentiate between X1 and X2. But you need to kind of say which point is the first point and which is the second point. So I like to make a little note saying that this is the first point, this is the second point. Doesn't matter which one you choose to be the first one or the second one, you're going to get the same slope no matter what. So this is going to be the x coordinate of the first point, because again, it's always, always, always x comma y. So this is the y coordinate of the first point. This is the x coordinate. This is the x coordinate of the second point. This is the y coordinate of the second point. Do yourself a favor and write yourself all of these notes out to keep yourself organized when you're learning how to do the slope formula, because it's so easy to mess this up. If you write it out like this, you kind of can't mess it up. So I'm going to now plug in y2, which is 0. It's the y coordinate of the second point. The slope that I'm looking for on that line that we were working on earlier, 0 minus y1. It's always minus. It doesn't matter what sign the coordinate point is. In fact, we're going to do this because there is an order of operations discrepancy between minusing and negative. If you were to just do 0 minus 2, that would be wrong, because this is -2. This minus and the negative attached to the coordinate point are 2 separate instances of a negative. And then we have x2, which is 3. and then minus, always minus, because we're just following the formula, 0. All right, let's simplify this. Subtracting a negative, if you remember, is the same thing as adding a positive. So this is just going to be 0 plus 2 over 3 minus 0. 0 plus 2 is 2. 3 minus 0 is 3. So for this line, the slope of it is 2/3. What does that even mean? We know the slope is just the steepness of the line, but there's actually a way to kind of look at that graphically. What the slope tells us is that, so for every walk to the right, we're going to go up by 2/3 of a distance. If we have a negative slope, we would be going over to the right by 1 and then decreasing it by whatever the negative slope is.